Welcome to Geometry Pre-AP, the greatest course in the world. Today we're going to be talking about the volume of pyramids. We're just dealing with this part of this today, volume of pyramids. We're trying to do them one piece at a time, so it's not too much information at once. So we go to our first slide here. What we need to do is we need to go over some basic details of information. So it says, what is the shape of the base for this pyramid? So a pyramid is called by its base. And so if we look here, the shape of the base of this pyramid is a square. And so that's the bottom part's not where the vertices meet. And so what type of solid is this? Is a pyramid. And so then name the base edges. So base edges, we're going to do those in red here. So these are the base edges. They are where the base is, and they are the segments that make the base. We'll name a lateral edge. So a lateral edge we're going to do in green. Lateral edges are where lateral faces meet, and so we know that from our first video on polyhedrons. These are the lateral faces here, or lateral edges. Okay, and it says name a slant height. Now a slant height is the height of one of the triangle faces for the pyramid. So this is the slant height. It always forms a right angle with the base edge as long as it's a right prism or right pyramid. Okay, and so that one was in blue. And then last, can you name an apothem? Well, this figure does have an apothem. Our apothem would be right here, which is GF. And then what is the height of this figure? Okay, so in this figure here, we're talking about, in this case, the solid. So what is the height of this solid? And the height of this solid, I'm going to highlight that. And so I'm going to go to my highlighter here. And the height of this solid is this yellow part right here. We know this is a right prism as long as that height is at a right angle to the base. And so then, do we have a height of a base? Now, this base here is a square, so we don't really have a height in a square, but if we had some other kind of base, say a parallelogram or something like that, then we could do it. We could find the height of a base. You know, if we had a trapezoidal pyramid, those are kind of unusual pyramids. All right, so I'm just going to pull these answers over here for you so that you could see all of them. And there are the answers, and there are all the segment pieces for all the lateral edges, the slant, height, and the base edges. Okay. So you can pause the video, write that information down. You're going to do one next. So here's our next one. I want you to take the time to do this one and answer all of these questions. So I'm going to put a star by this page here, and so you do all of those questions. Pause the video, answer those, and come back to class with those done. All right, so our theorem here for today is 12.9, which is the volume of pair. Volume of pair is equal to 1/3 big BH. And so let me remind you that, like I told you with prisms, you must do your big B work separately. So in this case here, if we have a square-based pyramid, we would use S squared. If we had a pyramid that had a hexagon, we might use 1/2 PA. And so for the most part, all the pyramids we're going to do will have some sort of regular polygonal base. We're not going to do ones with irregular bases like a trapezoidal pyramid, unless I do some sort of extension. All right, so here we have a picture, and this picture says that if we have this pyramid, and it says in each pyramid there are 4 different triangles that can be formed. They're all right triangles. It can be given information. You can be given any kind of information for one of them, but you might need a different piece of information to maybe solve the problem. So we have we have one right triangle where we have a height, an apothem, and a slant height. And so that's this blue one here that you can see back in the picture. We have an apothem, half the base edge, and a radius. That's this orange one right here. Actually, no, it's not that orange one. It's this red one right here. Oh, no. Oh, no, that's it right there. My bad. Okay, so the apothem, half the base edge, and the radius. Okay. Then we have a lateral edge, a slant height, and half the base edge. That's that green one. And then finally we have the last one, which is the height and the radius and the lateral edge. Now, this one right here, has the height in it. This one right here has the height in it. And so remember that in the formula, volume is equal to 1/3 big BH. We need that height to do volume. When we change and do surface area, we'll need the slant height instead. So there are all these different right triangles that we use to go find that height. So try to find the easiest one to work with, and given the information would help. So you might want to draw a picture or label those different triangles. Pause the video so you can get that information down. All right, so here's our first example problem. It says find the volume if the base edge is 8 centimeters. So we have an 8 here and an 8 here. And it says in the lateral edge, which is up here, which is not the slant height, it's the lateral edge, it's where the triangles meet. All right, is 12. And so we want to know this information right here. Oops, that's the wrong one. We need to use that lateral edge. We're going to do this right triangle right here. So we kind of need to look at that square, and I need that radius right there. Well, I could just go ahead and find the whole entire diameter of that square. So the radius, if this is 8, this is 8, this is 8 square root of 2 for the whole diagonal across the square, which makes this part right here 4 square root of 2. So this piece is 4 square root of 2, and this is my height. So I want to go do Pythagorean theorem. 12 squared minus 4 square root of 2 squared equals h squared. Now remember that 4 squared 2 squared is where some of you messed up on the last test. So let's make sure we simplify that correctly. That's 144 minus 16 times 2, which is 32, equals h squared. That's 112 equals h squared. H is equal to 4 square root of 7 when we simplify that. Now my big B work is a square, so it's s squared. So big B is equal to 8 squared, which is equal to 64. So volume equals 1/3 big BH. So 1/3 64 times 4 square root of 7. But when I multiply all that out, I'm going to get 448 square root of 7 all over 3. And of course, this was centimeters cubed. Okay. Alrighty. So now let's go to our next problem. This one I want you to do. So pause the video and find the volume of this figure. All right, once you're done with this figure, the volume of this figure will be 400 centimeters cubed. If you have a problem with working with that problem, make sure you bring it into class. Make sure you have tried something. You can't just put the picture down and no information. All right, let's go to our next question. All right, so here's our next question. We're going to find the volume of this regular pentagonal pyramid. So first of all, I think I'm going to need that apothem. So I'm going to need that apothem, and we need to go through that process here. So we know this angle right here is 36 degrees. Remember, we get that as 360 divided by 5 is 72, and then we have to bisect that central angle to get 36 degrees. This is my apothem. This is going to be 3 and 3 because the apothem bisects the side. So the tangent of 36 degrees equals the 3 over the apothem. So my apothem is equal to 3 divided by the tangent of 36 degrees. Our perimeter for our pentagon is going to be 5 times the 6, which is 30. And so my big B is going to be equal to 1/2 PA, which is equal to 1/2 30 times 3 divided by the tangent of 36 degrees. When I simplify this, 1/2 of 30 is 15. 15 times 3, I end up with 45 over the tangent of 36 degrees. So that's my big B. Remember that volume is equal to 1/3 big BH. So 1/3 big B is 45 divided by the tangent of 36 degrees times my height, which I go back and look at the figure, was 15. Now, before we start putting this in a calculator, I can do a little simplification. I can take the 3 and the 15 out and get a 5. And so then I can take the 5 times 45, which I end up with 225 all over the tangent of 36 degrees. And when I put that in the calculator, 309.686 meters cubed. I'm going to just round to the thousandths place. All right, so make sure you have those notes. That's good there. Have a pentagonal, regular pyramid there. All right, so here is an oblique pyramid, okay? Now, even though it's an oblique pyramid, all right, so here is an oblique prism. We can tell because it's kind of slanted to the top, but it is giving us this 11 yards. That 11 yards represents the height of the whole entire pyramid. It's not the lateral edge, it's not the slant height, it's just the height. So I think we need to first deal with our base, which our base is going to be equal to 1/2 PA. So that's 1/2. Our perimeter is going to be 4 times 6, which is 24. We know this is a hexagon, so we know that we have a 2 and a 2, and so then my apothem will be 2 squared root of 3. So half of 2 is 1, so we end up with 24 squared root of 3 is my big B. So volume is equal to 1/3 big BH. 1/3 24 squared root of 3 times my height. This number on the outside is the height. And so 1/3 of 24 is 8. So we end up with 88 squared root of 3. And of course, this is going to be yards cubed as my volume. So oblique prisms work just like any other prisms. You just have to look for the height in the picture. If they don't have it, you might have to do some work to find it. All right, so here's a little bit more of a complex figure here. We're going to work on finding the volume of this solid with a hole that's a pyramid-shaped hole in it. So if we look at the whole entire picture, we can see that the solid, the main thing, is a cube. And so the volume of the cube is equal to the B times the H, which is 10 squared times 10. So that's 1,000 is that volume. Now the volume of the pyramid is 1/3 big BH. The base here, we're going to have to do a little work. So if this whole side is 10, that makes this 5 and this 5, this 5 and this 5. And so these are right angles, so therefore I know this is 5 squared root of 2. So the base edges for this pyramid, since it's a square, is 5 squared root of 2 squared. Please make sure you do this one correctly. I'm going to write it out twice because so many people make a mistake. That's 25 squared root of 4. That's a 2. So I get 50 here. So my big B is 50. My height, well, the height of that pyramid is the same as the height of the prism that it's stuck inside of, which would be 10. So I get here 500 over 3 is the volume of my pyramid. So I got to subtract them. 1,000 minus 500 over 3. And so I end up with 2,500 over 3 inches cubed. I subtracted those volumes there. So the volume of the prism minus the volume of the pyramid. Oh, board's going a little crazy here. Minus the volume of the pyramid. All right, there we go. All right, you can pause the video and write some of that stuff down if you didn't follow that quick enough, and then go to the next slide. All right, so for this next slide, I want you to find the volume of this pyramidal shape. This is 2 back-to-back regular pyramids. They're both right pyramids. Pause the video, do the work on this, and then when you're ready to check your answer, turn your video back on. All right, when you're done here, the volume for this figure is going to be 16.698 centimeters cubed. Oh. I'm going to rewrite that down here. The board's going to look crazy. Volume is equal to 16.698 centimeters cubed. All right, and so that wraps up the end of our notes. Make sure you bring those notes in class. You may have some questions on some things. Write those down in your notes, and we'll take care of those when you come to class. Thanks, and have a good night.